Okay, graphs of rational functions can have a variety of shape and different functions. One of the features can be a vertical asymptote, which corresponds to what value in the equation? What makes it not? Oh, I know what you're saying, the zero of the original function. But if I were to look at the actual rational function, what would it correspond with? It would correspond with the non-permissible value. The bottom zero, yep. Not all non-permissible values result in vertical asymptotes. This is something new, grade 12. Sometimes a non-permissible value instead results in a point of discontinuity. In other words, a hole in the graph. So if you refer to it just as a whole, then if I ask you point of discontinuity on the test, you might not know what it means. So that's why I'm going to use it interchangeably. Okay, so we have something that looks like this. Y equals x squared minus 5x plus 6 divided by x minus 3. So it looks very complicated, but if we actually divide this, you'll see that it's a very easy function to graph. So before I actually did long division, I should always attempt to factor first, and this is nicely factorable. So this is what? X minus 3, x minus 2 over x minus 3, and the x minus 3 cancels. So we're left with y equals x minus 2. However, I did cancel out a non-permissible value, so I need to put a comma and tell the person that's graphing x cannot equal 3 because the original function had a non-permissible value. So you can't just take that away because you divided it out of there. So what is this? If I were to graph y equals x, it's a line. That's right. A point on minus 2, up 1 over 1, up 1 over 1. However, if I go up 1 over 1 again, I'll be now in the x equals 3 range. So what's going to happen? Skip it. Okay. So then up 1 over 1, put a point, up 1 over 1. Now, if I were to actually connect the dots, what do I do to represent a hole? Yes, it is an open circle. Very good. So this is actually what it looks like. So you might say, well, how am I going to know the difference between the hole and the vertical asymptote, right? So a vertical asymptote, that means that nowhere x can be 3. But here, it's just when x is 3 in this one spot. So if you think about this for a second, when we get close to a vertical asymptote, they either go to positive infinity or negative infinity. This is not. This is going closer and closer and closer and closer to this hole. It's not going to positive and negative infinity. So if I were to plug 3 in to the original, what would I get? But what would I get as the something over 0? I get 3 on top? 1. You get 0 on top and 0 on the bottom. You get 0 divided by 0 when you sub it in. So 0 divided by 0 is your red flag that this represents a hole. Versus the other time when you plugged it in, you actually just got a number other than 0 divided by 0. Okay, so we're going to go more and more. The other thing to know is, how do I know that it was going to be at 3, 1? Well, I knew because the trend was going towards this, which leads us to the first topic in calculus called limits. And what this is the closer and closer and closer I want to get to 3, what height is it intending to go, even though it actually doesn't get there? Well, that's what's called limits in calculus. So I could also put the 3 into this equation that's simplified, and do you see I get 1? 3 minus 2 is 1. So, however, if I put 3 into the original, I get 0 over 0. So that's how we actually end up solving limits eventually, is because of that. Okay, so we're going to do compare the two. They look very similar. What's the only difference between the two functions here?
There's a minus and one plus on the other.
Yeah, there's a minus in one and a plus in the other. So we're going to see how that will change the graph. It actually changes the graph significantly. So how are we going to graph this? Well, let's try to factor first. So f of x, if I factor the top, I can pull out an x, and I'm left with x minus 2. If I factor the bottom, I can pull out a 2, and I'm left with 2 minus x. Now, somewhere you learned in grade 11 pre-cal that if two factors are so similar except a sign is different, what do? Yeah, take out a negative. So you cancel it, and then you can stick a negative in there, right? So this is the same thing as negative x over 2, where x cannot equal what? What did I cancel? 2. Okay. Does anybody know what this looks like? F of x equals negative x over 2. What happens if I rewrote it like this? Negative 1/2 x. What is that? It's a line with the y-intercept is at 0, right? And down 1 over 2, yes? Oh, except what, if I go down 1 over 2, I get into the whole range there, so I got to put a little dot there. Then down 1 over 2. I could also go up 1, left 2, up 1, left 2. Do you see it looks like that? You should be using a ruler there, by the way. So it's a straight line, the slope negative 1/2, yes? Okay, so we have a hole. How did I know the hole was at 2, negative 1? If I sub 2 in here, what's negative 1/2 times 2? What's negative 1/2 times 2? Negative 1. That's where the hole is, right? Okay, so if I substitute 2 into the original, what do I get there? 2 squared minus 2 times 2 gives me what on top? 0. Then I substitute 2 here. I get 4 subtract 2 times 2. 0. I get 0 divided by 0. Does everybody see that when it's 2, I get a hole? Now let's watch on this one. So g of x equals, can I factor anything there? Yeah, I can factor an x, and I got an x plus 2. And I can factor this, and I get 2 minus x. Can I cancel anything? Can I cancel anything? No, I can't. There's nothing the same here, right? Okay. That's a 2 minus x, yeah. So if I can't factor and cancel, what's my next step? I'm sorry? Long division? Is that what you said? Yeah, long division is what I do. Okay, so now I'm going to go x squared plus 2x, and I'm going to have, now I'm not going to write 4 minus 2x because you're supposed to have it in decreasing order of x. So I'm going to write it as minus 2x plus 4. Does everybody see that? Okay, so how many times does minus 2x go into x squared? Ooh, that's a tough one. Okay, so I'll put a minus 2x there. What is minus 2x times minus 2x? Does that make x squared? No, try again. Negative 1/2. Negative 1/2 times negative 2 does give me positive 1. What else am I missing? An x, yes? Okay, so negative 1/2 x times negative 2x give me x squared minus 2x. Is everybody good with what I got? Now what do we do? Change the sign. I'm going to switch the signs in red. Bam, bam, there you go. So what happens? You get 4x. So how many times does minus 2x go into positive 4x? Minus 2? Not negative 2x, just negative 2. So negative 2 times negative 2x is minus 4x. Oh, I don't think that's going to work. Sorry, it's plus 4x. Yes, thank you. And then minus 2 times plus 4 is minus 8. Now I'm going to switch the signs. Bam, bam. And what happens? I get 8 as my remainder. So what does that mean? 8 over minus 2x plus 4. And then this is my quotient, so then I get minus 1/2 x minus 2. That looks kind of weird. That doesn't even look like what I used to have, what you did your homework on. Y equals a over x minus h plus k. Do you remember how to graph these? What do these letters represent? Okay, so let's compare this now. First off, this I can factor. What can I factor out of there? The bottom I can factor a minus 2, and I'm left with x minus 2. Yes? So I'm running out of room here. I apologize. I know you don't have any room. I'm going to write it higher up. So g of x is going to be, so does everybody see that 8 divided by negative 2 is actually negative 4 over x minus 2 minus 1/2 x minus 2? Okay, does everybody see what I did? I want 8 divided by negative 2 to get the negative 4 there. Okay, everybody good with what I got? So now I can actually see the vertical stretch is 4. The minus means it got a reflection. And the minus 2 meant that the vertical asymptote is shifted to the right 2. Does everybody see that? The only problem here is this k, which we just mentioned was the horizontal asymptote. It usually gets shifted up or down. What happened there? It went this way. So it's not a horizontal asymptote, it's what's called an oblique asymptote. Hopefully you've heard the word oblique before. So in grade 9 we learned that there's 3 kinds of lines: a vertical, a horizontal, and an oblique. Oblique is any line that has slope to it, right? Yeah? Just a general term for anything that has slope to it. So how are we going to do this? Well, we're going to graph the vertical asymptote. Yes? We're going to graph the oblique asymptote. How do we graph that? Well, that's a point on negative 2 and then down 1 over 2. That means, and I can also go up 1 over 2. It looks like this. A point on negative 2 and then down 1 over 2 gets my second, and then I make my oblique asymptote. We have usually we'll have then a floop and a floop here, but this negative now reflects it, so we'll have a floop here and a floop here, right? So in order to finish this off, we really only need 1 point in each of the quadrants. So I'm going to pick, say, I don't know, what's a good point to pick somewhere in here? 0. So I'm going to plug 0 into the original, and what do I get? Well, 0 goes in, I get 0 on top. What do I get on the bottom? 4. So 0 divided by 4 is 0. So I have 0, 0. Okay. And it hugs the asymptotes. Any point in the quadrant. You're only required to have 1 point in each quadrant. Well, okay. So normally if I would have picked a point, so say I thought it was in here. Okay, say. Then say I'd pick 4 as my coordinate. Once I plug 4 in, you'll see it'll push it down here. Well, it won't go in this quadrant here. Watch. 4 goes in there. What's 4 squared? 16. 2 times 4 is 8. So 16 and 8 is 24 on top. 4 goes on the bottom. 2 times 4 is 8. 4 minus 8 is negative 4. 24 divided by negative 4 is negative 6. So that is, do you see it pushed it down here? So the question was, how do I know which quadrant's in? Just pick a point. It'll automatically put it in the right quadrants, right? So I will again repeat, you only need 1 point in each of the quadrants. Normally, we would pick the 1s, right? Like when you did your homework, you would have the floops like this, you probably just had the 1 and the 1 there, yeah? Okay, so here's the great news. To be able to graph an oblique asymptote is what's considered an enrichment topic, so I won't actually test you on the graphing part of this, but you have to actually understand what makes this. So, first up, what makes this is, do you see both of these, you have a bigger degree on top than the bottom, so we divide. The second thing, okay, so it says explain the differences between the two near x equals 2. So at x equals 2, this goes to infinity and negative infinity, whereas at x equals 2 here, it's just a little point of discontinuity. It's not going anywhere. It's intending to go to -1, but it actually doesn't go there, right? Okay. In calculus, the term undefined is used for an vertical asymptote. While the term indeterminate is used for a hole, and I'll put point of discontinuity. So here's the key here, and I don't know how to highlight this enough. You have to know the difference between when you get a hole versus a vertical asymptote. So a hole is when you get 0 divided by 0, and a vertical asymptote is when you get a number other than 0 divided by 0. And using the term undefined for a catch-all phrase is incorrect. You cannot say 0 divided by 0 is undefined. It's not. It's called what's called indeterminate form, which means you have to do some work in order to get a specific answer, right? Undefined means no matter what you put in for that number, you're never going to get an answer, a value. So we're going to look at these equations and find if there's asymptotes, holes, and find any intercepts. So first off, A. What can we say about A here? The bottom is a different square, so why don't you just factor it so we can see more? Okay, what does the bottom tell you now? Tells you what? Some non-permissible values, right? So 3 and -3 are some no-nos. What happens if I plug 3 and -3 in there? Yeah, you either get 3 over 0 or -3 over 0. So what does that indicate? It's a vertical asymptote at x equals 3 and x equals -3. Or you could have said x equals plus or minus 3. Do we have a hole here? No, because the non-permissible values, when I plug it in, I didn't get the indeterminate form, so no holes. How about, so we'll put no holes. Okay, how about horizontal asymptotes? So I will repeat about horizontal asymptotes, even though some people have it through their head that a horizontal asymptote goes through the entire graph. The horizontal asymptote is only behavior at the far ends. So very big positive or very big negative. So let's plug in a very big positive. 1 million. Let's plug in 1 million at the top. Let's put 1 million at the bottom. Which one's bigger, the top or the bottom? The bottom by a lot. So if I take 1 million and divide it by a really big number, what would I get? A really small number. A really small number. So what's the smallest number without changing a sign? What would that be? 0. Yes. So that indicates that we will have a horizontal. If I pick 1 million at the far right, I'm going to get a horizontal asymptote at y equals 0. What happens if I put -1 million in there? Yeah. But still, you're getting a small, well, not a small number, but a number divided by a really big number. Yes. Yeah. So y equals, so it's probably going to, it's probably going to be curling up like that, right? And then this will be curling up like this on the positive and the negative. Do you see what I'm saying? So horizontal asymptote at 0, y equals 0. Is there an x-intercept? Again, it's not going through the entire thing there, so there is a potential to have an x-intercept. Sub y is 0 in there and solve it. What do you get? I will write it down. 0 equals x divided by x squared minus 9. This is where cross multiplying is your friend. Cross multiply that up. What do I get? 0 equals x. There's my x-intercept. Voila. If x is that, then my y-intercept must be that as well. Does everybody see that? If the x-intercept is 0, the y-intercept has to be 0, because it's right at the intersection of the x and the y-axis, right? Okay, so again, this is where you have to get your mind around that these horizontal asymptotes are at the far end. So let's do a quick sketch of what this looks like. This is just a quick sketch. We have a vertical asymptote at 3, a vertical asymptote at -3, and at the far ends it looks like this. So we have 3 quadrants here essentially. We have a quadrant here, a quadrant here, and a quadrant here. So how are we going to figure out what happens? Just pick some numbers in each of the quadrants and see if you can figure it out. So what would be a number on this side? Let's say 4, right? That would be on the right of 3. So 4 goes in there. 4 goes in there. What do we get? 16 minus 9 is 7, so 4 sevenths. So it'd be about here. So what's happening? There. Ooh, that's a horrible loop, eh? Try that again. There. There's my bloop. I knew it was in that quadrant because at 4, it's at 4 sevenths, right? Okay, how about this quadrant over here? Well, I could pick, say, -4. What do I get then? -4 goes on top. 16 minus 9 is 7. I get -4 sevenths. So where is it? Right there. There's my bloop. Okay. I also know another coordinate. It's going through 0, 0, because my x and y intercept is 0, 0. So what happens in this middle part? I don't know. So let's pick another point. It could go like this. It could go like this. It could also come and, come up to that point and come back down. I don't know. I need to figure it out. So yeah, let's pick 1. So 1 goes in there. 1 goes in there. What do I get for 1? -1/8, right? So say about there. Okay, let's pick something on the left of 0. -1. So -1 goes there. -1 squared is just 1. So I get -8 on the bottom. So -1 divided by -8 is +1/8. So it's like this. So guess what happens? Yeah. Oh, shoot. Okay, just for fun, I want you to pull out your graphing calculator and punch this in so we can do a comparison. Okay, so this would be something you need to actually be able to graph without a graphing calculator, of course. So this is x divided by bracket x squared, subtract 9. And I'm going to go zoom 6. And it looks exactly like our graph. Look at that. Does that not look like my graph? Sort of. I'm just going to shove it out of the way here. There we go. Okay. We're not going to graph everyone, otherwise we're not going to finish here. So I'm going to choose a different color. Let's do the next one. Is there a non-permissible value? Yeah, what is it? There is none, right? There's nothing you could plug in for x squared and add 1 to it and get a 0 out of it, right? Does that make sense to you? Yeah, anything that's positive or negative will be positive, and then you're going to add an additional 1 to it. So there's no way you could ever get a 0 out of it. Does that make sense to you? So there's no bottom zeros, which means what? No hole or vertical asymptote. No hole or point of discontinuity. No vertical asymptote. And why is that? Because no non-permissible value. Does everybody understand? The only way we can have a hole or vertical asymptote is if you have a bottom zero. If the bottom zero gives you a top zero, then we have a hole. If the bottom zero gives you another other than zero, then we get a vertical asymptote. Do we have a horizontal asymptote? We do. It's at zero. Very good. Does everybody understand how? It's the same logic as the last one. We're taking a number, pick a huge number, say 1,000,000, and then we're dividing by 1,000,000 squared. It's going to give us a really small number, right? And same if I flip it the other way, if I take a really big negative, then I'll just have a negative close to zero, right? So it'll be flipping the other way. Okay, do we have any x-intercepts? X-intercepts, that's where y is 0. Solve, what do I get? Negative 2. Y-intercept? You put x to 0. Yeah, it's 2. Notice that the y-intercepts are basically the constants divided. That's a little trick there. Quick trick. Notice also that in a rational function, if y is 0, that means this will automatically get cross-multiplied out of there, and really all you're doing is looking at the top, what makes the top 0, right? Okay, let's move on. Y equals x plus 4 over x squared minus 16. What should we do here? We should factor. Definitely not factor. What's the difference of squares? Yes? Then these cancel. Yes? So what are we left with? 1 over x minus 4, where x cannot equal what? 4? Negative 4. Okay. Well, because that's what I canceled here is a factor of x plus 4, which represents x can't be negative 4. Yeah, but it's implied right there. In a second, I'm going to put what there? A vertical asymptote. This represents the hole.
So when you can factor it out, that's when it's the hole.
Graph. Let's just do a quick graph. Does everybody see if this was my x and y axis, how would I graph 1 over x minus 4? Or would my vertical asymptote be? Yeah, my vertical asymptote would be at x equals 4. So right there? Yes? Where would my horizontal asymptote be? Y equals 0, and again, that's the far right. Yes? Far right, far left? Because again, if I pick a really big number and plug it in for x, you see I get a really small number when I divide. And the smallest, well, yeah, in the middle, there could be, if there's 3 quadrants, usually it goes through that part. In this case, you could get away with going all across just because there's only 2 quadrants and it won't end up going through there. But I want to get you to get your head wrapped around that this horizontal asymptote is only at the far right and the far left. It's not in the middle.
When does it start? Like the horizontal, you're just saying it starts at...
So you gotta, the horizontal asymptotes only represent end behaviors. So it's not like it's starting or stopping. It's just showing a behavior. It's showing that it's curling up to 0. Okay? It's more of a behavior rather than a, I don't know, a concrete thing. Okay? So what happens when I have negative 4 and I put that into the equation? The original, sorry. I get 0 over 0. That's a hole. So now tell me where the hole is. So you have to be able to tell me where negative 4 comma what it is. So this is where we plug it into the simplified version. Negative 4 goes in there. What do I get? Negative 1/8. So at -4, I'm going to have a hole at -1/8. Something like that. So how is this going to look? Again, a 1 over x minus 4, we have the 1 and the -1. And we just have a floop going like this, and a floop going like this. And it just has an extra little hole in there. That's the only difference. Why did I put the points where? When it has a 1 over, that means it's in the base graph, the 1, 1. It just got shifted over. So notice here the bottom is not bigger. So if I put a trillion into x and a trillion into that, this is, like if I subtract 2 to a trillion, does it make a dent in it really? No. That's why billionaires lend, $10. They don't really care if they get, you know what I mean? Like really, $2 is not going to affect a trillion. So, but if I take a trillion and times it by 4, it'll be 4 trillion divided by essentially 1 trillion. And what would I get if I divided that? 4. The trillions would cancel, I'm left with 4, right? Guess what my horizontal asymptote is? 4. Y equals 4. Yes. If you still don't believe that little trick, then you got to long divide. So if I long divide it and I go x minus 2 goes into 4x, how many times does x minus 2 go into 4x? 4 times. What do I get? 4x minus 8. Then I subtract, switch the signs. They cancel and I get left with 8 as my remainder. So that would be 8 over x minus 2. If I rewrite it just like we learned the other day, this would be 8 over x minus 2 plus 4. What does that represent? The horizontal asymptote that got shifted up 4. What do you think the x minus 2 represents? The vertical asymptote that got shifted right 2. But you already knew that by looking at the bottom 0. This is too much work, I guess, if you understand this, right? What does the 8 represent? Instead of the base graph of the 1, -1, it's now 8, -8. Bloop. That's all you do. Yeah. Okay, so vertical asymptote at x equals 2. Do we have a hole? Do we have a hole? No, no holes, no holes. No holes. If I plug in the non-permissible value 2 in, I get 8 divided by 0, which is a vertical asymptote, right? Okay, so I think we got everything. If I wanted to do a quick sketch of that, I would just go 2, 4, instead of the 1, 1, does everybody see the 1, 1? It's now going to be 8, -8. And it's really stretched out. Did it say to find the intercepts? Yeah, let's find the intercepts. I've been skipping that step, I guess. What's the x-intercepts? What's the x-intercept? Remember, that means y goes to 0. This essentially goes away, so it's 0. What's my y-intercept then? Well, it has to be 0. Let's go back to C. What's my x-intercept there? I don't think I said it there. What's my x-intercept? 0 goes in for y, so what is... How about -4? However, what's wrong with this problem here?
That's our indeterminate.
Can we have an x-intercept at -4 if x can't equal -4? No. So this is something you got to watch out for. That means, no, we just did it right now. That means we have no x-intercept because it's actually a hole at the x-axis. Oh, I didn't draw that one. I was drawing, I don't know where I was drawing anyways. Oh, I drew it. I drew this one wrong. Shoot. Because, no, that was right. That was right. So where my x-intercept is at -4. It doesn't actually cross there. So that's kind of weird.
Well, there's a horizontal asymptote.
Well, there's a hole at -4. It actually doesn't cross the x-axis. So even though it looks like we can solve it algebraically, we don't get one. That's why I'm saying sometimes the math doesn't jive, so you got to watch with what you've already proved. No, you know what I mean? Like if it shows that you get an x-intercept and it's a hole, you can't have an x-intercept. It doesn't make sense. No, stop it. I shouldn't say that in the video anyways. What's your y-intercept? What's your y-intercept? Remember, the y-intercept is just the, yeah, -1/4. Okay, moving on to E. Same degree at top as the bottom. I'll factor it just to make it look nicer. Okay, can anybody tell me the vertical asymptote? Horizontal asymptote, hole.
There are no holes.
Yes, note the horizontal asymptote is not going to be 0 because we do not have a bigger number on the bottom than the top. We have essentially the same. So when we divide the same number, what do we get? 1. Do you want me to repeat that? I put a trillion in top, I squared. I put a trillion in the bottom and squared, then subtract 1. It's essentially still a trillion squared. So I get 1. Yeah. Vertical asymptote, x equals 1 and x equals -1, or you could plus or minus 1. Do we have a hole? No hole. Do we have an x-intercept?
No, 0.
0. Do we have a y-intercept then? Yeah, if the x-intercept is 0, then the y-intercept has to be 0. Okay, moving on. What's the next one? What's my... Can I... What does this graph look like?
Yeah.
This one's a little bit more complicated because it's going to have 3 sections. So we're going to have 1, -1, and +1 here. And then we'll have to pick a point in each of the quadrants to see what happens. Yes, we will, but I'm going to save that for tomorrow's lesson. That was E I was talking about. Yeah, but I want to get through the analyzing part of it right now. Okay, horizontal asymptote, because if I graph everyone, I'll never finish this lesson, right? So, what's my horizontal asymptote here? Look at this. 3.
Oh, yeah, it's 3 times.
3 times a trillion squared, and then a trillion squared on the bottom. You divide it, you get 3, right?
But they have the same degree and you're multiplying by 3.
Yes. Essentially, that's what's going to end up happening. If they're the same degree, it's just going to be the leading coefficients divided. So you're seeing the little tricks here. Do we have a vertical asymptote? Do we have a non-permissible value? That would be no. Because we're squaring something and then adding 9. We can never get a 0. So no NPVs. So that means no hole, no vertical asymptote. What's my x-intercept? 0. What's my y-intercept? 0. Moving on. How about this one? I'm going to factor the top. I get x plus 4, x plus 1 divided by x plus 4. Hey, what happens here? Bada bing, bada boom. They cancel. X plus 1. X cannot equal. Okay, what does this represent then? A hole at what? -4 what? -3. How did he know it was -3? He subbed -4 in there. -4 plus 1 is -3, right? How did I know it was a hole? Because I subbed -4 into both the top and the bottom. I got 0 divided by 0.
Yeah,
Because I just put -4 in there.
No, how did you find out that it was a hole so fast?
Because anytime the factors cancel, I know that if I sub it in, I'm going to get a 0 times anything over 0, right? Okay, do I have a vertical asymptote? Do I have a vertical asymptote? No, the -4 was the hole. It can't be a vertical asymptote and a hole at the same time. So no vertical asymptote. Nothing makes a number divided by 0, right? What about a horizontal asymptote? What about a horizontal asymptote? What am I actually going to graph right here? A line with a hole. Does a line with a hole have a horizontal asymptote? No. No. X-intercept. Y-intercept. X-intercept. X-intercept. Well, it can't be -4 because that's a hole, so then it was -1. And my y-intercept? 1, very good. Okay, moving on, let's factor. Okay, let's factor the top. We get x minus 3, x minus 1 over x minus 3. That cancels, so we get x minus 1 comma x cannot equal 3. So, do we have a vertical asymptote? We have a hole. So no vertical asymptote. We have a hole at 3, 2. See, we're getting it. Horizontal asymptote. No, because we have a line with a hole. None, right? No horizontal asymptote. The only time we have a horizontal asymptote is if we have really big numbers and we're dividing and we either get really small numbers or, well, essentially that's, you have to have a big, the degrees either have to be the same or one bigger at the bottom. If this is bigger on top, you're going to divide and get a line or a quadratic or something. Yes, because the non-permissible value produced a hole. 0 divided by 0. X-intercept. X-intercept. 1. Y-intercept. Very good. Okay, how about this one? Ooh. This one's a tricky one. This is where... No horizontal asymptote. Very good. Why did we know it was no horizontal asymptote? Because it's a bigger degree. Now, do we have a vertical asymptote? Yes, we have a vertical asymptote at x equals 1. Do we have a hole? No, when we plug 1 in, we don't get 0 divided by 0. We get 6 divided by 0, which represents an asymptote. However, we do have a bigger degree on top. This is one of the ones where we divide and we get an oblique asymptote. Again, you won't necessarily need to recognize it, but you might want to recognize something like this, that there is no horizontal asymptote, I guess is what I'm saying. Is there an x-intercept?
So what do you mean, how do you know if there's no horizontal?
Okay, so x-intercept, is there? It's actually, it's the root of -5, so that means none, right? Y-intercept? -5. So I want you to go over this summary. So this is what we were supposed to get from this analysis. To get a vertical asymptote for a point of discontinuity, you have to have a non-permissible. If you don't have a non-permissible, you're not going to get any of those. A graph has no vertical asymptotes or point discontinuity if there's no non-permissible. So they're basically saying the same thing. To find the x-intercept, the point of discontinuity, and the vertical asymptote, you need to analyze the numerator and the denominator. A factor of only the numerator corresponds with the x-intercept. Well, that's what we found for the last couple, right? A factor of the denominator corresponds with the vertical asymptote. A factor of both the numerator and the denominator, remember we cancel it, that's where we get the whole. Okay, so the behavior again of the at the non-permissibles, you have to see whether it goes to positive infinity or negative infinity. That's where the floop, where is it going? You got to find where that goes. That's where we plug in a point. You'll see that tomorrow's lesson. A horizontal asymptote occurs at y equals 0. This is key. If you're asking about the horizontal, read this over and over again until you get it through your head. It's always at y equals 0 if the numerator is less than the denominator degree. If it equals the numerator, then it's whatever the leading coefficient dividing. And if if you look at the enrichment, that's the oblique stuff. So again, you need to recognize and see how you get the horizontal, vertical, and the whole.